we've found that sustainability doesn't sell itself. When we started the company, we thought that just having sustainable credentials would be good enough. But it was, well, what's my return on investment? How much money are we going to save?
Hi everyone, welcome to the Climate Confident podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, Rob. Rob, welcome to the podcast. Would you like to introduce yourself?
Thank you very much, Tom. It's great to be here. My name is Rob Atkin. I'm the co-founder and CEO of Pirta, a climate tech company.
And tell me a little bit about Pirta, Rob, for people who are unaware. What problem are you trying to solve?
So Pirta specializes in developing and commercializing passive cooling systems. These generally take the form of paint or additives that go into paints.
And why start with coatings and paints rather than insulation, HVAC, or better design or anything else?
The company was started really in response to things like air conditioning. Passive cooling systems are very efficient ways of managing temperature in a warming world. Legacy systems like air conditioning, they make up for about 15% of global electricity demand. That's unsustainable, and it's set to triple by the year 2050 as temperatures trend up. It's about twice as many emissions as the entire aviation industry is responsible from AC. So we wanted to have something that was intrinsically low carbon intensive, something that was sustainable, affordable, and easy to apply.
Okay, and what pulled you into passive cooling in the first place?
It's a bit like the conversation we had earlier where climate change is terrifying and we have to do something about it, where it's not a problem that's going to go away by itself. Necessity is the mother of all invention. And so as product designers specializing in things like insulation and heat recovery ventilation systems, my dad and I decided to start a company that was going to be a force of good in the world and help drive innovation within a sector that's not really known for innovation. Paint companies, they're led by the companies who make the additives for the innovation. We found a big gap in the market. We were trying to look for a cooling paint because we know these systems exist in nature. So biomimicry is a huge part of human innovation and invention. But we couldn't find anything that had the performance that we wanted to see. So we set to designing something ourselves. We didn't have any lab facilities at that time. So we just had a lot of coffee, did a lot of research, and then went into the garage and started designing our paint system.
Tell us about the paint system. What did you come up with?
So it's water-based. All the systems that we use are for water-based paints, and it's going to sound simple. There's a lot of work behind the scenes, but essentially what it is, it's a paint system that's beyond white. We've been painting our houses and buildings white for hundreds of years because we know that white paint keeps a building cooler in full sun than a dark paint. But it only gets you so far. When you look at the solar spectrum, white paint's really good at reflecting in the visible area of the light spectrum. But you've got the near infrared and you've got the UV as well. The UV is what gives you sunburn. That's at the kind of short wavelength area. And then the longer wavelength area, beyond the colors that we see as white, you've got all the near infrared. And to have something that is efficient enough to give you the performance to have what we call passive cooling, which is to actually cool a surface down below the ambient air temperature, you need to be really reflective in all of those areas of the spectrum. So we designed something that was white across the whole solar spectrum. As well as that, it's also emissive. It allows that surface to lose any heat that absorbs from the sun, so it can lose that heat as well. You could have something that was really reflective, like a space blanket, like a silver foil.
Yeah.
But anyone who's used a space blanket knows that they're really good for keeping you warm. So if you were to just have the reflectance, then that wouldn't allow a building to cool down efficiently enough. It would trap the heat inside. So you need to be able to lose any heat that's created inside and reflect away the energy from the sun. And that's essentially how passive cooling system works. If you want to think about emissivity, if you've ever had a a chrome towel rail
Hmm.
where you dry your towels. They get hot, but if you put your hand near them, you can't feel the heat being radiated from them. They've got very low emissivity. If that radiator was matte black, you'd feel a lot of heat coming off it. So that's something that our paint had to be, was both white and black at the same time. Sounds like the
In,
setup for a joke.
and does that mean then, though, that the buildings get particularly cold in winter and need more heating?
Not so far as we've found in certain pilots that we've run, and our customers like to run pilots over a long period of time to see what happens both in the summer and the winter to test that. We've found that when it's cold, it actually performs about the same as a normal white paint. You're going to limit some of the solar heat gain that you would get during the winter, but actually it keeps the temperature a lot more steady. So you don't get these huge curves of it spiking, getting warm and then getting cold. What we've found is it tends to stay more flat. That's a good thing. Typically, our customers, where we look to seeing the most benefit from this technology, they're not places that typically get cold anyway. So India, southern Spain, places like that, where it gets really hot and it doesn't get particularly cold. So we haven't found that to be a problem.
Yeah, sure. No, I live just outside Seville in Andalusia, and the summer temperatures here in August hit mid 40s in the middle of the day. Well, I guess the hottest time of the day is around 5 p.m. in August, and it's around mid 40s. And then in winter time, the daytime high is typically around 15 degrees C. So it rarely goes below freezing. It's usually the overnight low in winter is 5 to 6 degrees C. So, like I say, rarely goes below zero.
Yes, the net benefit you're going to get over the full year is definitely going to swing in the favor of having an efficient cooling system over an efficient heating system.
And is heat becoming a bigger business problem than many business leaders realize?
We're seeing it becoming an increasingly bigger pain point for a lot of businesses. AC can make up to 30% of a company's outgoings in warmer places. The challenge is to manage that, for one, to keep costs down, two, to be more sustainable, and also improve the working conditions of the people who are working in the warehouses. If something goes wrong with your AC system and it breaks down, and you don't have a passive cooling system, then you're going to have problems. A paint's not going to break down. There's nothing mechanical there to malfunction. As long as it's kind of kept clean, then it just sits there doing its thing without creating any additional cost, which makes it particularly effective for places. We've been running affordable housing projects where people can't afford air conditioning. So there, the kind of ROI is quality of life for big companies who are running a lot of AC. Their ROI would be payback on the cost savings from their AC unit.
And possibly worker productivity as well?
Absolutely. We've found that sustainability doesn't sell itself. When we started the company, we thought that just having sustainable credentials would be good enough. But it was, well, what's my return on investment? How much money are we going to save? That's just the way that business operates in the markets. It has to be a win-win. It has to do all of the good stuff whilst also being very affordable, and things like improving worker productivity. That's another thing. It's good for that, but it's also great for the fact that people aren't having to work in extremely hot conditions. That's the kicker for us. Again, with affordable housing, people who can't afford to run AC systems, and you find this kind of disparity all over the place in many walks of life. It's the people least responsible for something that tend to be the most affected, and that's climate change in spades. So what's the ROI for someone painting the house with a cooling system in the Caribbean? Well, it's quality of life, but
Mm.
also quality of life for animals in agriculture. So we run a project with chicken coops because there's problems with chicken coops overheating, and then the farmers get loss of productivity for their eggs and the meat. But it's also animal welfare, which is
Mm.
great for us, but That's kind of the reason why we go into it, but the reason for people buying our technologies it's climate resilience. It's becoming more and more important.
And it's not like I can go down to the shop and buy a can of Pirta paint, right? It's that your business model is you're selling it to the paint manufacturers rather than manufacturing the paint yourselves.
We do manufacture the paint. We've been doing that for pilots. The company's actually pivoting away from manufacturing paint. The problem with starting a paint brand from scratch is there's huge competition. It's not the most efficient way of getting our technology out into the world onto as many buildings as possible. That's why we've pivoted to developing the additives that go into paints so that then anyone can make their cooling paint. So we've got a new product, Nivi, which we're scaling up now. And essentially what this is it's a low carbon pigment solution that existing paint manufacturers with the routes to market and their brand loyalty can make cooling paint. It keeps the carbon footprint of the company low because we're not shipping water around the world like you would with a water-based paint. It just allows the company to scale and to have the biggest impact possible. We're talking to our first big distributor. We're in licensing talks with several other companies. Can't name drop at this moment, but we've got a lot more interest since we've switched to the pigment system. And what this allows our paint manufacturers to do, and this kind of comes back to the win-win return on investment, is because it's a low-cost commodity product now rather than a premium paint technology. It allows manufacturers to reduce the cost of goods from replacing legacy pigment technologies, which are the main cost within a tin of paint. It allows them to reduce their embodied carbon within that tin of paint. So it makes it greener, it makes it cheaper, and it allows us to scale and maximize the potential for passive cooling technology.
And the interesting claim here is that you're not just cooling better, you're using less titanium dioxide. Why, for people listening, is titanium dioxide such a big deal in paints?
So titanium dioxide it's the one option. There aren't really, unless people want to go back to, kind of lead in their paints, which I'm sure there isn't a big desire to do. It's the one white pigment that is ubiquitous. It's very energy intensive to use. It's hazardous. It's got a huge amount of embodied CO2. I think about 8 kilograms of CO2 are produced per kilogram of titanium dioxide. The numbers vary; they're quite hard to find, but it's big. It's used in food as well. I think it was recently banned from Skittles. It makes the color pop. I know it's been used in things like chicken nuggets and toothpaste and stuff. So it's everywhere, and because it's the main cost in paint, you're seeing an increasing growing market for extenders and different materials that people can put into paint to remove as much titanium dioxide as possible. It's the main source of cost as well within paint. So paint manufacturers are desperate to remove as much titanium dioxide to manage their rising material costs. So they use what we call extenders, and typically they can remove 10 to 15% of titanium dioxide. With Nivi, we've found that the sweet spot is between 30 and 50%, so you can dramatically reduce your titanium dioxide usage. And with that, as you remove titanium dioxide, the carbon footprint of the tin goes down.
And is the bigger breakthrough the cooling performance or the fact that it can slot into existing manufacturing without a major change?
It's both, and you find, depending on the paint manufacturer and their product portfolio, it can be both. So if you're wanting to use it for your decorative coatings and just lower the cost of those and improve your sustainability credentials, then you can use it for that. And if you want to use it for passive cooling, it does that as well because it increases the reflectance in the solar spectrum. So we found different customers want it for different things.
And you mentioned that titanium dioxide is highly toxic. How toxic is Nivi?
Not at all. We've designed Nivi from the bottom up to be safe to use and safe to produce. So the product you're getting is non-toxic and non-hazardous.
And if titanium dioxide is being used in, as you mentioned, chicken nuggets and toothpaste, is there a gap in the market there that you can jump in and, hand toothpaste manufacturers or chicken nugget manufacturers Nivi to use instead of titanium dioxide?
That's on the product roadmap. So yeah, food safe versions will be available at some point. Yes, there is opportunity for us to help fulfill that market as well. I think that currently been taken up by things like calcium carbonate, which are obviously found in like your indigestion medications. So calcium carbonate is food safe. We can also make Nivi food safe.
Your website cites very strong numbers on surface temperature and energy savings. So, what should people listening treat as proven today and what's still early stage?
We're very careful to make sure that we don't oversell and underdeliver. Everything that
Hmm.
we do, all of the figures that we publish, they're all figures that have been measured either through a third party. So we use third party labs to do a lot of our verification, or it's from real world pilots where it's temperatures that we've taken. So we've monitored the temperature of the roof, of the paint surface temperature, so that the information that we're putting out is it's recorded data. So it's not something that we've made up, or it's not an aspiration. We're scientists at the heart of it, so we want to record data and then we share that, so that what people are seeing is actual recordings from pilots and real world tests.
And you quote an SRI number, which is eye catching. For people who don't live and breathe material science, what is SRI and why does that matter in practice?
So the solar reflective index it's an ASTM standard, and this is something that's used across the cool roof market. And what it does is it takes the emissivity and the reflectivity of your product. So we measure the TSR, that's the total solar reflectance, and then we measure the emissivity. We use Leeds University to do a lot of our third-party validation and emissivity measurements. Also, SRI approved laboratories. It's all done to a specific standard. And essentially, what it does then is it gives you a surface temperature reading against a white surface, a typical white surface. And the higher that number is, the more reflective it is. So a dark surface will have a very low SRI. Once you
Mhm.
get to about 100, then you're in the passive cooling area. Standard white, I think, is about 80, but 100 is a very high performing number. And to get 117, that's, I think the SRA only goes up to about 130, so it's right near the top of what's possible.
Sure. And yours, as you mentioned, is 117. And what does an SRI above 100 actually mean on a real roof?
So it means that you're going to have a sub-ambient or lower sub-white paint, and the lower that temperature, the less energy is being absorbed into your building. So therefore, the less your AC is going to have to work to fight against that energy that comes into your building.
Okay.
So essentially, the higher the number that is, the lower your AC bills are going to be.
In all this journey, what have you found harder than expected in getting this from lab performance to commercial reality?
That's the hard bit. Creating prototypes, we found that's the kind of easy bit. To get the initial performance wasn't too hard. We did that in a few months. To turn that into a commercializable, usable product was the hard bit, and that's the bit that took years. Hand in hand with that is getting all of the third-party validation, having it tested. There's various standards that your product has to be before it go to market to make sure it's safe.
Mhm.
It was that took a long time. The early prototypes, they had the performance, but they're very difficult to use. They had a lot of drawbacks. There's a lot of barriers to market that we had to overcome technically before it became a paint that you could then put that on your roof. We've done a lot of that now for Nivi. we had to make sure, again, it was going to be affordable. It was going to be commercially viable to manufacture at scale. And it's those things that take a long time to make sure that it's safe. When we come out to do a food safe version that can go in your chicken nuggets, there's going to be an awful lot of regulatory testing that's going to have to be done before that. Even though we know that the materials in it are food safe, there's an awful lot of testing that will need to be done before that we know it's good, safe for human consumption. So that they will be the main barriers and the main challenges that we have to overcome. It's not just the lab scale.
And where does the likes of passive cooling have the biggest climate impact first? Is it like warehouses? Is it homes? Is it data centers? Is it factories? Is it something else entirely?
It's interesting you mentioned data centers, and we have an interest from data centers because those things are huge and they need to be kept cool, often built in out the way warm places. There is a lot of data centers in hot places, and I think there's a huge one being built in Utah. And from an environmental impact, it will be your big AC users, your hospitals, your warehouses, fulfillment centers, hotels, and also data centers. That's going to be the huge one, because as AI industry grows, so will data center building, and that's going to drive up carbon emissions from AC. So it's those kind of things that are going to have the biggest impact for the planet. So airports is another big one. Here in the UK, not many people have air conditioning systems. It's not until you step out into other countries that you see just how much and how prevalent AC usage is, and then you kind of start to understand and realize the full scale of the problem. It is going to get warmer in the UK. As our infrastructure also moves towards being more electric, so you're seeing a lot of new builds now being fully electric and not having the gas central heating systems. With that comes more electricity substations. They're prone and difficult to keep cool. Obviously, the more AC you use, the more those running costs are going to go up. So in order to help future-proof places like the UK from spiking energy prices, grid overload, passive cooling has a big application there. We kind of had built this for affordable housing and warehouses, shopping centres and things like that in mind. The more people we talk to, the more applications for the technology come up. And things like rail infrastructure, which is something that we never thought about. But you tend to find in a lot of places, the infrastructure is designed for the climate that we had and not for the climate that we have and the climate that we're getting. So rails buckling as they expand under the sun. And there's more calls on painting rails white to help stop them expand. Not the tops, they're shiny, and obviously a train-proof paint would be quite difficult to develop. But the side of the rails where they're dark, there's a lot of applications in rail infrastructure, data centers. The agriculture one was one that came up through talking to customers. So
what would need to happen for passive cooling to move from niche material to default design choice?
it has to win for the customer. They have to see a return on investment. They have to see that it's good value for money. And each use case is different. We like to analyze, when we're looking at a project, the data set of that particular building, its roof makeup, its global position, its roof area as a surface area of the whole building. Obviously, like if you've got a tower block and you paint the very top, it's not going to have a huge benefit. So that's why we're looking at wall solutions as well, which is important for places like Singapore. So it has to be a win for both the customer and hit all their requirements. That would be for the paint manufacturers as well, who are trying to manage their own material costs and reduce their titanium dioxide reliance. So for it to really kind of boom, we had to design Nivi as a commodity product, something that was going to have the least barriers to market, where it could have the most impact. The cool roof market is growing a lot. I think it's about 7%, 7 to 9% per year, and it's already a $20 billion industry. So cool roofs is already kind of moved away from being that kind of niche thing to already being a normal thing. If you look at an aerial photograph of Arizona, you'll see that all of the warehouses and everything has cool roofs. We tested our product against a cool roof. Now, a cool roof can be anything. They don't have to be particularly high performing to be called a cool roof. And we found that some that all customers are using, there's a good case study that we did in Miami for Miami-Dade County. And they already had a cool roof, and the conference room that we painted the roof of was still too warm, and that their AC unit was working overtime. So we went and we overpainted theirs with our system, and they didn't go back to it for a few days. And when they went back, they were like, "Oh, it's freezing in here." So, but when you look at cool roof markets, they're becoming less niche and more kind of standard. A lot of the major manufacturers who produce roofing membranes and things like that all have their own cool roof solutions. As we look at our Miami-Dade County thing that I was just talking about, you see that they're not as effective as they can be. So it's a huge growing marketplace, and we're not seeing it slowing down.
Great. And 5 years from now, what would success look like for this category, not just for Pirta?
So 5 years from now, what success would look like for Pirta, we'd like to see that the industry moves away from legacy paint systems towards more sustainable, low carbon, and more effective solutions. That technologies like this become standard. Our mission is to reduce the carbon footprint of a tin of paint. It's to help improve quality of life, and it's to drive sustainability and cut costs for not just corporations, but households as well. We saw a video from a pilot that we ran, and this was for an affordable house. And it was a lady talking about how her quality of life had improved since we'd painted her house. And this is a house with no AC, no insulation. I want to see more of those stories. Success for me is to see more people's lives being less impacted by climate change. And as global temperatures rise, this is just going to become more and more of a problem. It's going to be human tragedy stories all over the globe, and anything that we can do to do our bit is a win for me. So even if the company fails and no one wants to buy our Nivy, the fact that we've started improving quality of life for people, for me, it's improving quality of life and improving animal welfare. The fact that we can save people money is great. That's important to the investors. That's important to the commercial customers. But I think in 5 years' time, if we've been able to do that, even just a few times, this whole journey will have been worth it.
Okay, superb, superb. And a left field question for you, Rob. If you could have any person or character, alive or dead, real or fictional, as a champion for passive cooling, who would it be and why?
Kind of left field question. This is like one of those Friday night conversations where they're better when you've had like 5 pints. It's got to be someone from the scientific community. Albert Einstein. Albert Einstein would be a really good champion for our technology. He could really help us with the maths as well, because he was pretty good at the old math. Was Albert.
Okay. Rob, we're coming towards the end of the podcast now. Is there any question that I didn't ask that you wish I had, or any aspect of this we haven't covered off that you think it's important for people to think about?
A question that we get asked a few times, and it's I quite like to get this out there, is the word Pirta. So people ask why we're called Pirta, because it's a bit of an unusual name for a paint company, and Nivy as well. And these we've picked these names specifically. They're Inuit words. Pirta means blizzard,
Wow.
and Nivy means snow. And we picked these because the fundamental kind of mission of why Pirta was founded was that the people most affected by climate change are the least responsible for it. So nomadic communities like the Inuit will be hugely affected by climate change. And they're not the huge multi-billion-pound corporations burning loads of fossil fuels. So it's to protect those communities, and it helps keep us grounded, keep reminding us why we're doing what we're doing.
Rob, that's been really interesting. If people would like to know more about yourself or any of the things we discussed on the podcast today, where would you have me direct them?
So you can go to pirta.com. That's our website, where you can find a lot of information. Education's a big part of the business, so there's a lot of interesting articles and information on there about passive cooling and climate change, things like the urban heat island effect. So feel free to go there. There's an email address where you can contact us if you'd like to find out any more information.
Tremendous. Rob, that's been great. Thanks a million for coming on the podcast today.
Thank you so much, Tom. It's been a pleasure.